talked about what inverses are and how they reflect across the line y equals x, we are going to learn how to find the equation of an inverse function when we are starting with an equation. So we've done it in a table. We've seen how to do it graphically by changing the ordered pairs. Now we're going to see how to do it when we don't know the individual ordered pairs. So we're going to have to learn how to manipulate an equation to find the inverse. And then we will graph to double check to make sure that they are indeed reflecting over the line y equals x. So to change the equation into an inverse, we're going to first change our f of x to a y. So if you look at example 1, that's actually not going to be a thing because we're starting with y equals. But sometimes we start our equation with f of x, like example number 4, and we would have to switch that to a y. Okay, so letter A or step 1 is already done in the first example for us. So then step 2 or B says we're going to switch the x and the y in our equation. So that just means that we're going to look at our x and our y and we're going to swap places with them. So instead of y equals, we have x equals 4y plus 8. Okay, because we're reflecting it across the line y equals x. So now our y is equal to the x and our x is equal to the y. Like our ordered pairs where we just swapped our x and our y value, we're doing the same thing with our variables. Okay, step 3 or letter C says solve for y. So we're going to need to be doing some manipulating of this equation to isolate the y again. So now we have x isolated. I need to move the 8 and I need to move the 4 to get the y back by itself. So I'm going to first subtract 8 from both sides. So I have x minus 8 equals 4y. And then to get the y by itself, we're going to divide by 4. We're going to divide each of our terms on the left by 4. Okay, so we get x over 4, which is also a 1/4 x. And then 8 divided by 4 gives us a minus 2, and that's equal to y. So we now have y by itself because this 4 divided by 4 cancels out. Okay, and then the last step says we're going to replace y with f inverse of x. So you see that exponent of -1, that doesn't mean that we're going to do anything with the function. That just shows that it's not the original, it's the inverse. So we will write this as f inverse of x equals, and we're just replacing this y. So the other side stays the same, 1/4 x minus 2. This would be the inverse equation. Okay, remember I said we could start the beginning of our problem with f of x. Ooh, that's really ugly. Okay, we could start it with f of x equals, and our original was 4x plus 8. So by changing that to f inverse, we can tell which one was the original and which one is the new inverse. Now, if I wanted to graph these to check, I could definitely do that. So I'm going to go over to Desmos, and we had f of x equals, or y equals, because remember we do have to type that, y equals 4x plus 8. So there's my original one. And then if you remember, the inverse I found right here is 1/4 x minus 2. So 1/4 x minus 2. Okay, so there's that line. I have the original, I have the inverse. I can zoom in on it if I wanted to. And then if you recall, those are supposed to reflect across the line y equals x. So I'm going to go ahead and graph that line, y equals x. Okay, if I were to fold my screen along that line y equals x, you'll notice that I do reflect over that. So the top red piece would reflect over that right side of the blue line. If we looked at it ordered pairwise, the red line, we have a x-intercept at -2, 0. If we wanted to find the inverse of that, remember we switched the x and the y values. So that means the blue line should have a value of 0, -2. So if I click right here, yep, 0, -2. Okay, so those do reflect across the line y equals x. Let's go do another example over here. Okay, so this one I do start with an f of x. So remember the first step says we're going to switch the f of x to a y. So we have y equals 7 minus 5x. Step 2 says we're going to switch our x and our y. So I'm going to take the x and the y and trade places. So this is going to be x equals 7 minus 5y. And then step 3, the longest step of everything in this process, is to get the y by itself. We need to start by moving the 7 because it is the farthest away from the y. Okay, reverse order of operations. So we start at the bottom with any addition or subtraction. This zeroes out. We get x minus 7 equals, should be a negative 5y. Then we're going to divide both sides by negative 5. Okay, so I have x over negative 5. We can call that negative 1/5 x. Or you can leave it like it is. Okay, and then negative 7 over negative 5 gives me plus 7 over 5 equals y. So you can either write it like this, or you can leave it as y equals x minus 7 over negative 5. These two things are exactly the same, and you would need to be able to recognize either form if it were a multiple choice problem. Okay, and then our last and final step would be to replace dy with f inverse of x. And I'm going to just leave it as x minus 7 over negative 5. Okay, of course, you could go and graph that in your calculator to see if it reflects over the line y equals x. You would use your original, f of x equals 7 minus 5x. And then your f inverse of x equals x minus 7 over negative 5. Okay, let's look at this next example. We've already got the y replaced. This one's going to be a little bit different because it's a quadratic function, or it's a parabola. So I'm going to go ahead and swap my x and my y. X equals parentheses y plus 2 squared minus 3. We're going to start by adding 3 to both sides. So we have x plus 3 equals y plus 2 to the second power. So I can't get inside my parentheses until I get rid of that squared term. And if you remember back, probably in geometry when you were using Pythagorean theorem, to get rid of anything that's to the second power, you're going to take the square root. So that's going to be the inverse of squaring something, taking the square root. So the square root and the square over here cancel out. On the left, I have square root of x plus 3 equals, and then on the right, I'm left with a y plus 2. And I don't have to have it in parentheses anymore because there's nothing on the outside of it now that we got rid of that squared term. Now, here is where you're going to run into the biggest error of the whole problem. I need to subtract this 2. And I think everyone would agree with that. However, when I'm subtracting it, it may not go under the radical. It may not go inside that square root because square root is kind of like parentheses. Whatever is inside of it has to stay inside of it. Whatever you bring over after you take the square root has to stay on the outside. So this is going to be the square root of x plus 3 with a minus 2 on the outside. You cannot simplify that to square root of x plus 3 with the minus 2 under, so x plus 1. It does not work like that. Okay, that would not be able to combine because they're not like terms. One of them you're taking the square root of, the other one you are not. So then for our final step, we would just write f inverse of x equals square root of x plus 3 with a minus 2 on the outside. Now, I am going to graph this with the original. So here's my original up here, and here's my inverse. I'm going to type those into Desmos because you're going to see that the whole entire graph does not have an inverse. So I'm going to leave y equals x on there. Whoops, never mind, accidentally deleted it. Okay, so we're going to start with y equals, and my original was x plus 2 in parentheses, x plus 2 in parentheses, whoa, I missed my 2, squared, with a minus 3 on the outside. And then my inverse was the square root of x plus 3, I believe, with a minus 2 on the outside. Yep, the minus 2 on the outside. Okay, and then I'm going to graph the line y equals x so that we have that to look across. So you'll notice that only half of our parabola, half of our blue, lines up with that green function I'm going to go ahead and take a screenshot of this and bring it into Notability so that I can kind of show you and draw on it. So let's put this picture in. All right, so looking here, you'll see that this part of the green lines up with this part of the blue. I think we can agree with that. And this part of the blue lines up with this part of the green if we were to reflect it. Okay, I think we all agree with that. But the other half of our blue parabola over here does not have anything reflected on the green. So if it were to reflect on the green, it would come like this to make the other half. So this would be our inverse right here, this big horseshoe shape. So that's not our inverse, or I should say, we're going to have to restrict our original one when we get to this unit because this does not pass the vertical line test. So that would not make a function. So that's why when we have our square root, it only graphs half of the parabola as the inverse. It only graphs this part right here as the reflection. Because if it were to graph the whole thing, we wouldn't have a function for that square root. So once we get to that unit, we'll talk more in depth about why. But I just didn't want you to be freaked out if you graphed your answer to check and you only saw half of it showing up. So that is correct. We did find the correct inverse because we can tell that the inverse does have a direct reflection onto that parabola. We'll talk later on about what happened to the rest of our parabola. Okay, so that's just a side note. I didn't want you to get freaked out in your graphing that everything didn't show up. Okay, so for number 7, if we wanted to determine if these are inverses, you could choose one to start with. It doesn't matter if you start with f of x or g of x, and you would just find the inverse. So like if I started here, I would switch my x and my y like this, and I would solve for the inverse and see if it got me what g of x says. Okay, so you're just solving one inverse to see if it matches up to the other one. So I'm not going to do that example. Down here, I wanted you to see ordered pairs. For some reason, freak everyone out because they're just a little bit different presentation. But if you think about it, these are the same thing as having a table of x and y values like this. So really, to find the inverse in a set of ordered pairs, you're just reversing them. So this first example, my inverse would be -4, 0 because I'm switching, and then 3, -4, 2, 3, 1, 2. Okay, so no reason to freak out about those. Now, I did want to work one that has a fraction. So for this one, we have a fraction. I'm going to replace f of x of y with y, and I'm just going to do it like that. Okay, so I did step 1, replace f of x with y. Now I need to switch my x and my y values. So x equals -2/3 y plus 7. Okay, I'm going to move that plus 7 by subtracting it on both sides. So I get x minus 7 equals -2/3 y. Now, to get rid of a fraction, we're going to multiply by the reciprocal. So multiply by the reciprocal. So reciprocal means we're going to flip it. And we keep the sign the same, okay? Not the opposite reciprocal, just the reciprocal. So I'm going to multiply this side by -3/2 as well. So these cancel out, and on the right, I just have a y left. Over here, I have -3/2 x, and then if I distribute it over here, -3 times -7 is plus 21/2. Because remember, we multiply the top, keep the bottom, because 7 does not have a denominator. So I could say for this one, f inverse of x equals -3/2 x plus 21/2. And if you technically wanted to leave it like this with -3/2 on the outside and x minus 7 on the inside of the parentheses, that's fine. But this way over here is going to allow you to graph it by hand if you choose, because you have a slope and a y-intercept.